So that last video cut off a little bit, but basically knowing if the degree of the numerator is greater than the degree of the denominator, we won't have a horizontal asymptote. There will be a slant one instead that we'll talk about next week. So after you identify the horizontal asymptote, now you're going to factor. So the first thing you're going to want to pick out is the domain. The domain is all real numbers except x values that make the denominator equal to 0. And these are the excluded values that we've talked about. So once you identify the excluded values by factoring, those excluded values are either going to be vertical asymptotes or wholes. So vertical asymptotes are the excluded values that don't cancel out. When I say don't cancel, that means when you're simplifying, if there's nothing on the top and the bottom to cancel out, those are the excluded values that don't cancel. And what we do is write as equation of a line, a vertical line. The other situation we're going to have is a whole, and these are the excluded values that do cancel. And what we want to do is write them as an ordered pair. And then the ordered pair is going to be your excluded value. And what you get when you plug that excluded value into the simplified equation. And we'll see an example of this in just a moment. So a couple of more things that we want to point out. To find the y-intercept, all we're going to do is plug in 0 for x, so long as it's not an excluded value. If it is, we're not allowed to plug it in. And then write it as an ordered pair. To find the x-intercept, we're going to set the numerator equal to 0 and solve. And again, write it as an ordered pair. Now, setting the numerator equal to 0 is the same as putting a 0 in for y. You're just saying that the function is equal to 0, which means the numerator would be equal to 0. So that's all the information. So let's see a quick example. So let's take a look at the function x minus 4 over x squared minus 2x minus 8. The first thing before I factor, I'm going to point out the horizontal asymptote. Since the degree of the numerator is less than the degree of the denominator, automatically y equals 0, the equation of that line will be the horizontal asymptote. Then what I'm going to do is go ahead and simplify this, factor the bottom, and then cancel out that common term, which leaves me with 1 over x plus 2. Once I've done this part, that's going to kind of clue me into the domain. The domain is anything that makes the bottom equal to 0. So the domain is all real numbers, but x cannot be equal to 4 and negative 2. We can also write this in interval notation, which you should be able to write it in both. We should be able to write them in both ways, but that's coming from, those are the two numbers that would make the bottom equal to 0. Now, those excluded values are either going to be wholes or asymptotes. The one that's left over will be the vertical asymptote. So I'll have a vertical asymptote at x equals -2. What happened at the other one is I have a whole. I have a whole at x equals 4. But remember, we want to write a whole as an ordered pair. So to find what the output would be, you plug 4 into the simplified function. So it would be 1 over 4 plus 2, which is a 6. So the whole is at 4, 1/6. We can go ahead and find the y-intercept by plugging a 0 in for x. And it doesn't matter if you do it here or here. You would get 1 over 0 plus 2, which is a half. Writing it as an ordered pair would be 0, 1/2. And the x-intercept, you take the numerator and set it equal to 0. Now again, you can do it here or here. If you do that first one, you get x equals 4. However, that is an excluded value. So we can't really have that as our x-intercept. If you take this one and set the numerator equal to 0, that just doesn't even make sense. So either way, this is telling us that there is no x-intercept. So let's take a look at what this is going to look like on the graph. And this is what we're going to focus on next week. I know I have a horizontal asymptote at y equals 0. I know I have a vertical asymptote at x equals -2. I also know that there's a y-intercept at 0, 1/2. And I know that I'm never crossing the x-axis because I don't have an x-intercept. So 1, 2, 3, at 4, 1/6, I have a whole. So based on this information and what I know about rational functions is that the one branch is going to come here and kind of scoot along the horizontal asymptote, and the other one's going to be here. We're going to talk next week about how I knew that it was going to look like that. But this is all you need for now, and you should be able to work on the worksheet that's posted on Schoology.